Hi folks, I'm Mr. Olson. Let's do some econ. This is micro, topic 1.6, consumer choice and utility maximization. To start, what I want you to think about is what is your favorite thing to eat? And while you're thinking about that, I want you to walk through a little thought experiment with me. Let's say it's a cookie. Okay, let's say it's a delicious warm chocolate chip cookie. And I want you to imagine after school today, you go downstairs and you eat that first delicious chocolate chip cookie. Okay, how are you going to feel afterwards? How satisfied are you going to feel? How delicious is it going to be? Okay, and then I want you to think about what would happen if you ate your second chocolate chip cookie, and then your third, and then a fourth, and then a fifth, then a sixth, and finally a seventh chocolate chip cookie. How would you feel afterwards? How satisfied would you be? Okay, well, chances are the first one would be amazing. The second one maybe is good or almost as good, but eventually over time, your satisfaction would start to go down from consuming something, even if it's your favorite thing in the entire world. Okay, and this illustrates the concept of something called diminishing marginal utility. And this is so important that we call it a law in economics. It's the law of diminishing marginal utilities. And all this says is eventually that as you consume more of anything, the additional satisfaction you receive is eventually going to start to decrease. So diminishing means decreasing, marginal means additional, and utility means satisfaction, right? So this is the law of decreasing additional satisfaction. Okay, the more you buy of any good, the less satisfaction you're going to get from any unit consumed, right? And this is true for anything. Let's say for your 16th birthday, you got a car and you were so excited and it was your dream car, and the first time you got to drive over to your friend's house or drive over 17 to head to Santa Cruz, it was the best thing in the entire world. There was nothing better. But for each hour over time that you consumed driving your car, the satisfaction is going to decrease, right? It's going to wear off. The novelty is going to eventually decrease, and you're not going to be as excited. Okay, as a consumer, how does this apply to consumer behavior? Okay, well, we're going to assume that you're going to do anything so long as the marginal benefit is greater than the marginal cost. Okay, and we're going to assume that we're constantly, as self-interested rational actors, evaluating our decisions, and we're going to do anything as long as the marginal benefit is greater than the marginal cost. Well, we have to take into account the law of diminishing marginal utility, because the optimum times you're going to do something is going to be impacted by this law. Okay, so let's start looking at some problems where we could create scenarios to see how this plays out. And the first model we're going to build is with slices of pizza. Okay, so maybe you're at Pizza My Heart this weekend and you can consume anywhere between 0 and 8 slices of pizza. And then that's going to give you a certain number of utils, okay, measured to measure your total utility. Utils is just satisfaction points. So in economics, we're going to create utils to imagine that we could really accurately measure your satisfaction points. In reality, can you do this? No, right? It's much more of a theoretical concept, but in economics, we're going to put numbers behind it so we can measure it and illustrate these concepts. Okay, so this is going to show our total utility. The first thing you want to do is always figure out what your marginal utility is. Okay, in order to do that, you take the change in the total. So feel free to pause the video if you want to, and I want you to see if you can complete this column, calculating the marginal marginal benefit of each slice. Okay, and hopefully you got some numbers that look like this. Okay, in a lot of these problems, you might get a measurement of utils or you might get a measurement of dollars. Okay, we're going to imagine that you got satisfaction out of something that was equal to a certain dollar value. Okay, so this would be what our marginal benefit column would look like. Okay, and you can see here, by the time we got to our 8th slice, we are actually having negative utility, right? Which you could probably relate to, that sometimes if you overeat in something, you actually feel worse after eating that last unit than you did before. Okay, so but here's the question: how many pizzas would you order and buy if the price per slice was $2? So let's imagine, okay, that that each of these slices were $2 each, and these were the additional benefits that you would get from each slice, and this is the total utility. Go ahead and pause the video and think for a second. What is the optimum number of slices of pizza to consume? Okay, and here's how we would figure this out. Okay, we're going to create a marginal cost column, and we're going to do this in a whole bunch of different ways throughout the whole year. But we took some initial data that we got from the question, and ultimately the way we're going to solve these is we're going to want to compare our marginal benefit and our marginal cost column. Let's decide what we should do. Let's look at our first slice of pizza. First slice of pizza is so delicious. We're going to gain 8. Our benefit's going to be $8. It's only going to cost us 2. Should we eat that? Absolutely, of course. Second piece of pizza, diminishing marginal utilities kicking in, so we're only going to get $6 in benefit, but it only costs us 2. Should we have that second piece? Absolutely. Third piece, we're going to benefit 5. It's only going to cost us 2. Should we do it? Heck yeah. Fourth piece, we're going to benefit 2. It's going to cost us, we're going to benefit 4. It's going to cost us 2. Should we consume it? You betcha. Fifth piece, it's going to give us $2 in benefit, and that's how much it's going to cost us. Okay, so we could consume that. Our marginal benefit is equal to our marginal cost. That's going to be our optimum place to stop. If you keep going, now by the time we get to our 6th slice, we're only going to get $1 worth of benefit, but it's going to cost us 2. So why would we ever do that? Why would we ever pay for something if our benefit's not going to at least equal to what we're willing to pay for? Okay, so that means the optimum number of slices of pizza you should consume is 5 pieces of pizza, and that's because that's where our marginal benefit equals our marginal cost. And in consumer choice theory, what we're going to assume is that you're going to do something until the marginal benefit equals the marginal cost. Because of the law of diminishing marginal utility, the marginal benefit's always going to be changing, right? So we're going to have to take that into account when we figure out how much of anything should you consume. Okay. Now, we can do this for looking at vacations as well. Okay, so I want you to imagine that you're planning your next vacation, and your goal as a consumer is to maximize your utility. It's to maximize your satisfaction. So I want you to think about for a moment, based on the information I've given you now, which vacation would you choose? Most of you would say you'd rather choose Tahiti than Chicago. Well, because it gives you more utility, right? You're going to get 3,000 satisfaction points out of Tahiti, whereas in Chicago, you would only get 1,000. Okay, but we're not taking something into account here. What are we not taking into account? Well, it's the cost of going to those places. Now let me give you some more information. Now that I've given you the price, and I told you the Tahiti trip was going to cost you $3,000, or the Chicago trip was going to cost you $500. Now, which vacation would you choose? Okay. One strategy we could use is we could calculate the marginal utility per dollar of each vacation. So for every dollar you spend on your vacation, how many satisfaction points were you getting? Well, Tahiti was actually only giving us 1 util per dollar, whereas Chicago was giving us 2 utils per dollar, right? So we actually got more bang for our buck on the Chicago trip. Okay. And what this type of thinking allows us to do is compare different products with different prices. So even though these trips aren't the same price, we could put them in like terms by measuring them in marginal utility per dollar. Okay. And based on that information, I think most of you might choose to go to Chicago. Okay, so those are some background scenarios. Let's look at a more fleshed out scenario that is going to help us apply these principles to a different scenario. And they're going to look like a lot like the FRQs you're going to get in this class. I want you to imagine that you are with your friends at Gulfland or some adventure park, and that your mom gave you $40 to spend for the day. So that's going to be your budget constraint, $40. You're gonna want to choose $40 on this day, having fun with your friends, and you're considering a couple different options. Okay, you can go to the movies or you can go karting. Okay, and the essential question we're looking at today is what's the optimum combination of movies and go-kart rides that you could take in order to maximize your utility. Okay, so let's take a look at the chart that we've been given here. This is how many times you see the movie, and this is your marginal utility that you get from each time you see the movie. And you can see that the law of diminishing marginal utility matters here. Okay, and then over here we have go-karts. Go-karts cost us $5 each. Movies cost us $10 each. So for each time we see the movie, we're going to pay $10. For each time we ride the go-karts, we're going to pay $5. And you can see our marginal utility here of the first, second, third, and fourth time we see ride on the go-karts. Okay. In order to solve this problem, we want to put them in like terms. So we're going to want to we're going to calculate marginal utility per dollar. All you do for that is you take the marginal utility of that trial for each activity and you divide it by the price. Okay, so I'll start and then you guys can finish it. First time we see the movie, we're going to gain 30 utility points, and we're going to divide that by the price of $10. and that's going to give us 3. Okay, so first time we see the movie, we're going to get 3 marginal utilities per dollar spent. Okay, go ahead and pause the video and finish these 2 MU over P columns. Okay. So hopefully you got these numbers. Whoops. So hopefully you got these numbers. Okay. Now that we put them in like terms, we can start spending our $40. So here's what we're going to do. What's the first activity that we should do where we're getting the most bang for our buck, where we're getting the most margin utility per dollar? Well, it's definitely going to be seeing the movie the first time. Even though it's more expensive in terms of dollars spent, that's going to give us the most satisfaction. So the way to solve these problems is actually to circle it, and you're actually marking for yourself, all right, that's the first thing I'm going to do, right? And so we have our $40. We're going to see a movie once, which means we spent $10. So we should keep consuming. What's the next thing we want to do? As measured by margin utility per dollar, we're going to want to see the go-karts the first time and then the movie a second time, okay? Because those are both worth 2 utils per dollar spent, okay? So we've watched the movie twice. We've ridden the go-karts once. Let's stop and think about our budget constraint. We had $40 to spend. We've now spent $20. We've now spent $25. So let's keep spending. What are we going to do next? Well, based on the marginal utility per dollar, we should see the movie one more time and the go-karts one more time. What's our total spending now? We've spent $30 on movies. We've spent $10 on go-karts. So we've spent $40, which means we're maximizing our utility based on marginal utility per dollar spent. So the optimum number of times to see the movie is 3 times, and the optimum number of times to see the go-karts is 2 times. That's how we would maximize our utility, okay? I also want you to notice that we stopped when these 2 things were equal, okay? If you run out of money when your marginal utility per dollars are not equal, then you mess something up. These are contrived scenarios, right? These are fake scenarios. This is a logic that you use all the time, right? When you're trying to decide what you want to do, say you're at Disneyland with your friends and how many times do you want to go on Big Thunder versus Space Mountain versus the teacups, you're actually doing calculations like this all the time in your head. This is a contrived scenario. We're imagining we can quantify it perfectly, but so they're always going to make the math work out. You're always going to run out of money when your marginal utility per dollar is equal. If you run out of money when those aren't equal, then you probably messed up some math, and you should go back and check it. Okay, so we're arguing that's the optimum number of trials for each one. Now, stop for a second and think about total utility, right? So what's happened to our total satisfaction? So question number 1, how much is the total utility from 3 movies and 2 go-karts? Okay, if you stop for a second and add that up, you would get 75. Let's pick another combination. What if we instead, for question number 2, went to 2 movies and 4 go-karts? Then how many total utils would you get? Okay, you would get 68. So you could play with all the different combinations, and you can see that your total utility is maximized when you do the combination that we figured out using that strategy. Now let's take a moment and look at a real AP microeconomics FRQ that uses the same skill. All right, so the 2 products we can consume here are apples and oranges. We have total utility columns, and it tells us the price of each item here. Each apple costs $1, each orange costs $2, and the consumer is going to spend all his or her income of $7 on apples and oranges. Okay, they're going to waste all their money on just fruit. Anyway, okay, so part A. Using the concept of margin utility per dollar spent, identify the combinations of apples and oranges the consumer will purchase. Explain your reasoning. In this class, anytime you see the word explain in an FRQ, I want you to underline it because there's always going to be a point associated with that. So in this case, we get 1 point for identifying the combination, and then we get 1 point for explaining our reasoning. Okay. Anytime you see a total utility column, you almost always need to create a marginal utility column. And in fact, for all these, what you need to end up getting is your marginal utility per dollar, and then start ticking them off just like we did in the last question. If at any point you want to pause the video and jump ahead of me and see how you're doing, feel free. Okay, but I'm going to keep working through and show you what to do. Okay, I'm going to put the prices up here. So each apple is $1. Each orange is $2. So let's calculate our marginal utility per apple. First apple we consume, the marginal utility, the total utility is 20, which must mean our marginal is 20. Second one is 15, then 10, then 5, then 3. We can see the law of diminishing marginal utility impacting how much we're enjoying each apple. Let's go over here to oranges. What's our marginal utility? Again, if you haven't signed up yet, you got to take my calligraphy class this summer. Really, I'll help you with your penmanship. Guaranteed penmanship growth or your money back. Okay. Marginal utility, first orange, 30. 20, 15, 10, and then 5. And again, all I did to get that was find the change in the total. The marginal is the change in the total. Okay. Now, we're still not done because these are the different marginal utilities, but we have to take into account the different prices. So because these are only $1 each, this column is actually already our marginal utility per dollar of apple. Okay. But we need a marginal utility per dollar spent oranges. So all we're going to do is take our marginal utility per dollar divided by 2. So first orange is going to be 15, then 10, then 7.5, then 5, then 2.5. Now that we put them in like terms, let's start spending our money. First thing we should do is consume our first apple, and I'll go ahead and circle it here. Next thing we should do is consume our second apple as well as our first orange. And let's see how we're doing on money. So far we spent $2 here and $2 here, so we spent $4, so let's keep spending. In terms of our utility per dollar, the next best thing to do is consume our third apple as well as our second orange because they're both worth 10. So we'll do that here. And that's when we're gonna get to $7. So we've consumed 3 apples and 2 oranges, and we've spent a total of $7. Okay, so that's the answer for part A. Combination is 3 apples and 2 oranges because the marginal utility per dollar spent is equal and we're out of money. Okay, and that's why that's the optimum combination. Okay, let's move on to part B. The prices are going to remain constant, but we have more money in our income. So now we got a raise, we got a little extra allowance, and now we have $12 to spend. So what's a combination of apples and oranges that we're now going to purchase? So we've already spent 7, so let's keep spending money. What's the next best thing to do? Buy our third apple. What's the next best thing to do? Excuse me, I misspoke. That's our third orange. What's the next best thing? Our fourth apple and our fourth orange. Those are equal, 5 and 5. Let's stop and see how much money we spent. We spent $4 on apples. We've spent $8 on oranges, so we spent 12 bucks. That's perfect. So our new optimum combination here is going to be 4 apples and 4 oranges. Okay. And what's the total utility we'll receive from consuming that combination? We have a total utility combination here. So 50 plus 75 is going to equal 125 utils. That is our total satisfaction based on the way we decided to spend that 12 bucks. Okay. Part C, with our income remaining at 12, assume the price of orange is increasing to 4. Identify the following: the combination and the total utility. Okay. So now we're going to get a little bit messy here, as if we weren't messier yet. Now we're going to argue that oranges are 4 bucks. So just intuitively, you want to think about this. Oranges got more expensive. What are we probably going to do? We're probably going to consume fewer oranges. Okay. So at $4, what's our new marginal utility per dollar spent? Okay. We're going to start knocking those off now. So this was marginal utility per dollar of 2, and then the price doubled. So we're just going to divide this column by 2. So we'll get 7.5, 5, and what is that? 3.75. We're never going to get there, so I'm going to stop. Okay. So let's just start spending our 12 bucks again. what do we want to do? First thing we're going to do is our first apple, then our second apple, then our third apple, then our first orange, then our fourth apple, and then our second orange. Okay, so now we're at margin utility per dollar of 5.5. Let's check and make sure we've spent all of our money. 2 oranges now cost us $8, and the apples are $1 each, so we spent $12. And our new optimum combination is 4 apples and 2 oranges. And what is the total utility as a result of that? It's going to be 100, because we're going to consume 4 apples still. And then we are going to only consume 2 oranges, which is going to be here. Okay, so our total utility went down because oranges got more expensive. Okay, so sorry, that last slide was so messy. Here is the official AP rubric, so you can get a little bit more clarity about what the answers were, but that's how you tackle those problems. The final element of the analysis we're doing here is called the utility maximizing rule. And that says that when consumers are spending their money, they should spend, so the marginal utility per dollar of one good equals the marginal utility per dollar of the other. And that's actually something we've been employing with those problems. And it's actually a rule that you need to be able to implement independently of all the information we had on the last types of problems, okay? This little identity you can write down and apply, and it just says if you're deciding how you should spend your money on 2 items, you should spend your money until the margin utility per dollar of one good X, equals the margin utility per dollar of another good, in this case, good Y. Okay. And this is something you're subconsciously doing all the time, right? So let's go back to the Disneyland example. If you're at Disneyland and you have 8 hours to spend, even though you don't have money in that example, that you always have constraints, right? In that case, it would be time. And you have to decide how many times are you going to ride each ride until you get that kind of optimum level of consumption where your margin utility per dollar of one thing is equal to margin utility per dollar of the other. So it's something we do subconsciously when you're trying to divide up your time and resources. What we do in economics is create scenarios so we can put numbers behind it. Okay, so let's look at a element of a real AP exam FRQ that checks if you can apply this rule. So go ahead and pause the video, see if you can figure this out and apply the utility maximizing rule. So Sasha spends all of her income on peanuts and bananas. That's a little bit weird, but that's your choice, free market. Anyway, Sasha, here we go. So the last unit of peanut consumed increases her total utility from 40 to 48 utils. What does that mean? It means her marginal utility of her last peanut consumed was 8. And then the last unit of the banana consumed increased her total utility from 52 to 56. In other words, her marginal utility of the last banana consumed was 4. If the price of peanuts is $1 and Sasha is maximizing her utility, calculate the price of a unit of bananas. Because we know she's maximizing her utility, that is telling us that for Sasha, the marginal utility of a peanut divided by the price of peanuts equals the marginal utility of bananas divided by the price of bananas. Okay, so we know she's utilizing this rule because they told us she's maximizing utility. So all we do is got to plug in our numbers. Okay, so for peanuts, we got 8 marginal utils for every $1 spent, and then we got 4 marginal utils for every price of banana spent. Okay, so that's all we got to do, plug in the numbers, solve for X, and you would get 50 cents. Okay, so the price of a banana is 50 cents. And we know that's true because she's maximizing her utility. If the price of peanuts increase and the price of a banana stays the same, how will her purchase of peanuts change? Well, she would buy fewer peanuts because peanuts got more expensive, which is going to make her marginal utility per dollar spent decrease. Okay, let me flesh that out a little bit more to explain a bit more of the why on that. So we were at 8 peanuts, 8 utils per dollar spent on peanuts, and then we were at 4 per 50 cents spent on bananas. Okay, based on this last part of the problem, what happened? Peanuts got more expensive. So let's flesh this out as an example. What would that mean? That would mean, let's say the price of peanuts went to $2, okay, which would mean that her marginal utility per dollar of peanuts was only 4, which is less than her marginal utility per dollar of bananas, which was 8, right? And so what does that tell us? Well, if we're getting more marginal utility per dollar of bananas, then we should consume more of those, right? So we should spend less of our budget constraint, which in this case was, we don't even have a budget constraint, but if we had a budget constraint, how would we better utilize our money? Well, we should buy fewer peanuts, and with that extra money, we should buy more bananas, okay? Because the law of diminishing marginal utility tells us the more bananas we buy, the more this number is going to decrease, and the fewer peanuts we buy, the more this number is going to increase, right? Because the law of diminishing marginal utility. So just for the sake of argument, if we bought more bananas and fewer peanuts as a result of this change, they might equal out again, where we're consuming until our MU over P is, say, 6 for each, because they meet somewhere in the middle, right? So that's an example of how this rule is applied, okay? One more practice question for you. This is a multiple choice question from a real AP exam, testing to see if you know this rule. So pause the video, see if you got it right. To maximize utility, a consumer with a fixed budget will purchase quantities of goods, so the ratios of marginal utility of each good to its price are equal. Okay, that's basically taking the rule and seeing if you can figure it out in a multiple choice question format. There you go, folks. That was topic 1.6, consumer choice and utility maximization. Take care. I'll see you in class.